buttons there correctly. Thank you. And we'll come over here. So again, there's two handouts up here on the front desk over here. We'll be going over those today. The handouts are related to SQL. They're going to be related to our first quiz related to SQL. We will not be having a quiz this week, though, so these handouts are for the quiz for next week. Figured that you had a lot of stuff due today in particular, so I wanted to give you a little bit of a break from quizzing, and so no quiz this week. Question?
You provide a lot of stuff. You mean like the one assignment?
The one assignment for you, two assignments for people also doing the Twitter coronavirus. Yeah. So again, due tonight at midnight, the Twitter coronavirus homework. About half of people have submitted that so far, and the Flask on Docker homework. Still, a lot of people have yet to submit that, and that's totally okay. Not late at this point. You have until midnight tonight to submit that. And a handful of people have asked for extra office hours or a chance to meet with me again before submitting these things. So again, I'll be available immediately after class. Stick around in the hallway over there as long as people have questions. And I'll also be in my office today from noon to 1 p.m. For anybody who would like to come and ask questions during that time. Recall, again, that the late penalty for this class, the way it works is there's this exponential decay on the number of days late. And so if you're only 1 or 2 days late, that's only 1 or 2 points. It's basically inconsequential. This is designed so that if you do submit just a couple days late, not a big deal. But once you start getting into 3 or 4 or 5 days late, then the exponential really adds up, and very quickly you get to 0 points. Also recall that for most things, it's very difficult for me to award partial credit, and so it is usually better to submit correct work late than incorrect work on time. I already mentioned this already, but no quiz this week. And one last announcement, just real quickly going over the outline of the rest of this class. We're having a big sort of transition in our material this week. Again, up here in the top, I'm in our topic 4 folder. And you can see we're starting to talk about SQL. In these next 4 weeks of this class, we're going to really be focusing on what I call how to make SQL correct. So really understanding what the SQL commands are doing semantically, and both reading SQL commands, understanding what they're going to do, and writing your own SQL commands. In my opinion, this is the most important section of the course, and there's many reasons for that, but one of them that is interesting to students, especially graduating students, is that we will, over the next 4 weeks, be covering the SQL material that's commonly found in the data science technical interview process. And through talking with many of you are going through the interview process at places, and so my hope is that this next 4 weeks will help prepare you for those interviews if you are going to sort of data science-y positions. Most students also find this next 4 weeks, the material, to be much more straightforward than the last, sort of the first 4 weeks of this class, the first part of this class. Some of the reasons for that are there's sort of like only one concept that we're covering. We're not integrating many concepts, which in the first part of the class, we went really fast through a lot of things, only loosely covered things that you had to do in your labs and homeworks. That's not going to be the case in the next 4 weeks. Everything will be much more straightforward. No weird error messages that you'll be fighting against, having to figure out what exactly is going on. And again, the purpose, of those first 4 weeks, and especially building up to Docker, was so that we could introduce this database called Postgres. We saw in your Flask on Docker homework that this is how Instagram stores all of their data. It's how most companies today store most of their data. And so that's going to be the main tool that we'll be using throughout these next 4 weeks. We'll also be having a midterm based only on the SQL material up here. So it's, SQL only, no Docker, no Bash, none of that other stuff, only on SQL. It'll be a take-home exam on one of these 2 dates, either over this weekend or over spring break. I tried to design the exam so it's fairly short, just like could be done in person in under an hour, but I give you a lot of time to do it just so that you can schedule things however you'd like. And scores on this exam are usually very good. Scores throughout this whole sort of section here are usually very good. But I often have averages on the exam of like 99%. Yeah, much more straightforward midterm. And again, so if like, I don't know, some of the material from the past 4 weeks feels confusing, you don't fully understand things, there are still weird edge cases that are keeping you up at night, that's okay. You're not gonna have to be an expert on all that for the midterm, just the SQL stuff that we're gonna be talking about here starting today. And then after that, we'll be, instead of just talking about how to make SQL correct, going into how to make SQL fast, and that'll be sort of the last bit of our course. Any questions on anything administrative? Yes. The question is, how will you be evaluated on your Docker abilities? And the answer is, you will not have any sort of test situation, no quizzes, no tests related to Docker. We will probably not get to, well, we will see today in class how why Docker is necessary in order to talk about SQL. So we will be running Docker commands in class today in order to talk about the upcoming quiz, for example. But the only way that you'll need to know Docker is so that you're able to use the SQL stuff. And so you'll be tested on the SQL stuff, but not tested on the Docker directly. Good question. Any other administrative questions about anything? Okay, we will start today with some non-technical background on database systems, and then we will get into the technical details about things. So the particular type of database, the most common database, and the type that we'll be using is called a relational database, or RDBMS, for Relational Database Management Systems. And programmers really like databases. It doesn't matter what the problem is, a database is a solution. And that's sort of what this Dilbert comic here is trying to tell us, that here's this pointy-haired boss saying that we have some sort of problem that we have to do, and Wally here saying that we have to build a database. And Dilbert agrees with him. And we always like databases. Engineers, programmers always should be turning to databases as like the first line of defense in storing data. And we'll be talking a lot about the reasons why that's the case over the rest of this course. So SQL stands for the Structured Query Language, and it's the language that we're using to access the database. We've seen that a little bit with SQLite so far. We're going to be using that a lot throughout the rest of this course. And here I have most real programmers in quotation marks. So what I consider to be real programmers, but not everybody. There are good programmers who would disagree with this, but most real programmers pronounce it like SQL and not SQL. And the idea of this Dilbert comic down here is that the pointy-haired boss, he says, I think we should build an SQL database. We know that he's pronouncing SQL instead of SQL because it's an and right here, an SQL database. And so Dilbert goes, uh-oh, there's this person who doesn't know what he's talking about coming up to tell me what to do. So that's sort of the joke of this comic right here, that it's an SQL instead of a SQL database. Why do programmers pronounce it that way? 2 reasons. One is that programmers are lazy. SQL is 2 syllables, SQL is 3. So it's faster to say SQL. So lazy people prefer the faster thing. But historically, maybe more importantly, SQL was originally actually called SQL, the Structured English Query Language, but there were some trademark reasons that they had to shorten it to SQL back in the 70s. And there's the whole history of SQL posted on the ANSI blog. This is the American National Standards Institute who defines the SQL language, and their official recommendation is to pronounce it as SQL. We've seen that the shell invented in the 70s, the SQL also invented in the 70s, and we saw that the shell had lots of sort of warts because of this old because of its long heritage and need for backwards compatibility. We'll see many similar things with SQL. But just like the shell has been around for 50 years now, it's probably going to be around forever in the future. SQL's the same way. You're going to have to get comfortable with SQL no matter what sort of future job you go into. SQL is going to be a part of it. Some high-level comparisons to other languages. Normally we divide languages into two categories. Imperative languages, things like Python or the shell, they specify how to compute. An imperative is a command, so you issue commands to the computer with Python in the shell. But SQL is not an imperative language. We don't issue commands. Instead, we declare what we want the computer to compute. And the compiler or the database will convert this declarative code into imperative code. It will convert the what we want into a how to actually do it. And one of the very nice things that we will eventually see is that the resulting code will have provably guaranteed excellent performance, both asymptotically. It'll be asymptotically optimal. There is no way to make SQL code inefficient, and also with good constant factors. So that's one of the main advantages of this declarative style of programming, is that everything is going to be guaranteed to be fast. Let's see, a couple more non-technical things before we get into technical details. ORMs, Object Relational Mappers. These are libraries that hide the SQL interface to the database. They're very popular for beginner programmers, very unpopular for more experienced programmers. The reason for that is they make it so you don't have to learn SQL, so you can use your normal imperative programming knowledge. But if you do that, if you use one of these ORMs, you lose this guarantee that you have always provably guaranteed excellent performance. So for that reason, more experienced programmers prefer to just hard code SQL. Reddit famously uses the SQL Alchemy ORM. This is the same library that was used in Flask on Docker. You notice or recall that in that homework assignment, you never wrote any SQL commands directly in your Python, but the Python was still interacting with the database. That's because it was using the SQL Alchemy ORM. Another famous ORM is Ruby on Rails. Twitter famously started with it, but they were not able to scale with it, so they left due to its bad performance. And sort of a common takeaway from people is that just learn SQL. Like, skip the whole ORM step, just learn SQL, and then you'll be able to interact with the database correctly, the way the database wants to be interacted with, and get the good performance. So that's why in this class we are going to be spending so much time working with SQL, starting today. So this is all that everything we've talked about so far is related to these relational databases, RDMSs. There are two other popular categories of databases called NoSQL databases and graph databases. We'll be sort of comparing and contrasting our relational model against these two models at different points in this class. But sort of my main argument is going to be that you should not be using these things, and you should probably be using the relational database. Okay, almost at the technical stuff. One last thing for us to discuss: a comparison of main relational database systems. So I'm going to go to this colorfully titled website right here, and this has a comparison of all of these sort of famous database systems and why you might choose one over the other. In this class, we're going to be focusing on Postgres or PostgreSQL and SQLite. But here are some other famous ones that you may have heard of. If you have worked with, or depending on some of your intro classes that you might have taken, you might have used the MS SQL database. A lot of the economists like using MS SQL. They like spending money on things, and so MS SQL is something they can spend money on and feel like they're being productive. But it turns out that Microsoft SQL has a very bad reputation in the programming world, and there's a famous incident, for example, where a nuclear reactor was running with on a MS SQL database, SQL Server database, and ended up having a bad nuclear incident because they were relying on Microsoft SQL. And that's taking a little bit long to reload, so I won't go over there. Another common intro database for non-programmers is MS Access. Another has a very poor reputation among programmers of deleting your data when it's not supposed to. So avoid doing that. Excel, commonly used as a database among non-programmers. We'll see lots of features that Excel does not have. And here's an example of people using Excel lost tens of thousands of COVID results at the beginning of the COVID pandemic because they were relying on Excel, and Excel had a bug where it could not store more than 65,000 elements inside of it at one point. Oracle is a very famous database. It is very expensive, though. Licenses for Oracle cost multi-million dollars. Banks commonly use Oracle because laws often require banks to use Oracle, and banks are very rich, so it's probably okay for them to use this very expensive database. But if you are not super rich, then you probably can't afford Oracle. But Oracle does have a really good reputation. Last one over here before we see the ones that we've seen. MySQL is another famous database. This was very commonly used, again, in the 1990s as part of that LAMP tech stack. Facebook started off famously using MySQL, but MySQL has had a number of bugs inside of it that cause data loss in various ways. And so it's not the worst thing in the world to use MySQL these days, but it's not the most popular one to start with. These days, Postgres right here and SQLite are the most popular things to start with or to use for new programs. With SQLite, the sort of catch to SQLite is that you can really have only one person connecting it at a time. And if you really do only have one person connecting to the database at a time, then SQLite is a great thing to use. Again, all of your cell phone apps have SQLite databases inside of them. SQLite is, at this point, the most installed program in the world with hundreds, thousands of trillions of instances running. Postgres is the most famous or the most commonly used database, again, these days for things that have many users connecting to them at once. Sloaney here is a little bit of an older technology that builds off of Postgres, but it is a sort of like a backup system. We won't be using it in this class, and so this is the most sort of like resounding thing that this website is willing to say about any database. The best recommendation it has is that you're probably okay if you use Postgres. You're probably not going to have your data magically disappear. We don't want to guarantee that database people, we're very careful with our data, and so we want things to work 100% in all situations, guaranteed. We'll even see situations in this class where like your computer is subject to radiation and that's randomly flipping bits in the machine, and Postgres is still able to work in that situation and guarantee that your data is not going to get deleted. So database popularity from Stack Overflow, another fun-ish link that to show you. So again, MySQL used to be like 99% popularity. The popularity is going down though, and Postgres and SQLite are sort of the two main databases that people like to use these days. There's a survey on Stack Overflow of however many respondents, 63,000 respondents of people who actively use Stack Overflow, what technologies they use at their companies. Last thing, well, okay. So my summary of things, if you can't install Docker, then you should use SQLite. Otherwise, if you can't install Docker, then you should use Postgres. And then the very last thing is that even Microsoft uses Postgres instead of SQL Server, their database system, when they have large-scale database needs. This link right here takes you to a description of what happens when you press, I think it's Control-Shift-Escape now in modern Windows. that every time you do that, all the stats of your system are being logged to Microsoft, sent over to their servers, and they log all of that information inside of a Postgres database instead of a SQL Server database. A lot of high-level, non-technical, maybe interesting, maybe boring things, but any questions about that? Any of those things before we get into technical stuff today? Yes? So the question is, if there's no way to make SQL inefficient, why do we need to spend those extra 6 weeks to make things faster? That's a good question. I think the answer will be clear maybe during those 6 weeks. I guess there's no way to make things super inefficient, so there's no way of making something that's like a linear algorithm go to an n-squared algorithm, for example, which is very easy to do in Python. Actually, one of the most common sources of bugs in imperative programming languages is having a quadratic algorithm somewhere in your code that doesn't manifest itself as a problem with small data, but then a larger data set comes in and the program crashes. Every major website has had bugs like that have happened to them, where this like accidentally quadratic situation happens. That can't happen in SQL. The last 6 weeks of the course, when I say making things go fast, I'm thinking about like parallelizing things over multiple machines. So interacting again with sort of complicated Docker systems that way, or taking, I don't know, really sort of hardcore optimization things. So we'll see a full answer to that question during that time. But yeah, good question. Yes?
When would you use NoSQL?
Question is, when would you use NoSQL environments? This thing over here, this website, I never ended up clicking on this NoSQL thing. Database people have a lot of scorn for NoSQL systems. There's several popular NoSQL systems. MongoDB is the most popular one. Cassandra DB is another popular one. They get their name up here, NoSQL, because there is no SQL standard for accessing them. And the main problem with them is there's no guarantees that the data will actually be in the database after you put the data in the database. So we will later on be getting into talking about how Postgres guarantees that the data stays in the database once it's in there. And when we do that, one of the case studies that we'll see is that the Guardian newspaper, they used to store their, use a NoSQL database, MongoDB, as their backend database. And it turns out that they have permanently lost forever like 10% of their news article collection because of storing things inside of MongoDB when they probably shouldn't have been. These databases, what they're designed for systems like Facebook, where if you click on a like on Facebook, nobody really cares if Facebook remembers that or forgets that. But if you're like a bank where you're storing money, or you're a newspaper where you're storing articles, or you're storing anything where you actually care about your data and you want it to stay in there, then a NoSQL database is not something that you'll want to use for that situation. And again, we'll go into that comparison in depth later on in this course, probably about 5 or 6 weeks from now. This will be closely related to the sort of performance issues that we were mentioning, talking about from the last question. So great questions. We'll fully answer those later on in the course. Okay, fun technical stuff now. There's two submodules posted in this this folder here. The Pagilla homework right here. This is your homework for the week. You're welcome to take a look at it, although we were not going to talk about that today. We'll talk about that on Thursday in class, how to get started with it. Today we will talk about the SQL quiz submodule. And if you click on that, it'll take you over to the SQL quiz GitHub repo. Inside of this repo, you can see there's a handful of files. The things that should jump out to you right away are the Docker file right here and this docker compose.yaml. So the quiz, in order to run our quiz problems, we'll need to be able to use Docker for evaluating the quiz. And then there's a handful of these SQL files right here, .sql files, that will contain the actual problems that we'll be running inside of our Docker containers. The handouts up here, the large handout with the staple is this quiz example, is this quiz notes1.sql. This is the large handout right here. And the smaller handout is the quiz example1.sql. So the smaller handout is like an exact replica of what your quiz is going to look like. I'll just change out these problems down here with something slightly different. And this quiz notes contains all of the notes about what you're expected to know related to SQL. And you can see that there are many, many, many notes down here, many example problems that I'm expecting you to understand here. For studying for the quiz, this is going to be a good resource telling you exactly what I think is the things that you need to know for the quiz. Also on the main class webpage down here, under the this section right here, what you must know for the homework, midterm, and I guess this should be /quiz over here as well. There's these explanations about the select statement and the join statement, and it's the appropriate links over here to this postgresqltutorial.com website, which will serve as the textbook. So if you want an additional resource to read about all the things that we're going to talk about in class, this is the place to look. And if you go there, there's section 1, 2, 3, and 4. That's what you'll be responsible for this sort of first quiz. And then upcoming quizzes will go over the later things in this website. So this is, again, sort of like our textbook for this section of the course. In order to work with these quiz files, the README down here sort of explains what's going on. I'll let you read through this first section sort of on your own. But the important things for our lecture today are going to be this section running from SQLite and running from Postgres. For each of these quiz problems, you'll have to be able to run those problems both in the SQLite database and in the Postgres database and understand how those two databases are going to behave the same or behave different on the different SQL queries. So we'll start today by walking through the commands to just get the database systems up and running in both of these scenarios. And I recommend, again, that you follow along so that you're able to, outside of class, reproduce these steps and work through these quiz practice problems. So we'll start with SQLite first, and then we will do Postgres. Over here, I'll press come over to my my terminal screen. I have two terminal windows, both opened up to the Lambda server right now. And I'm going to go inside of my project folder in both of them. Again, this is just to keep things organized, where I like to put all of my projects that I'm working on. And we will git clone https://github.com/mikeisbicki/sql_quiz like this, and hit enter. And now I have this folder that I can go into, and I have all of these files from GitHub. Quiz, ls, both my terminal windows in the same folder down here. And what I want to do in the top window, again, I always have multiple terminal windows open when I'm working on something on the Lambda server. In one window, I use Vim to look at files that I'm interested in, and in the other window, I run commands. So here, what I'm interested in is this readme.md file, and I'm going to come down to the spot where it was talking about SQLite 3. So again, I hit / to do a search, and then in goes to the next instance of everything that I was searching for. And so now I'm at the running from SQLite 3 section that we were just looking at on GitHub. But now that I'm down here, or inside of the terminal, I can easily copy and paste things between my two different sessions. And what it's saying right here is in order to create a SQLite database, I run this command right here. So sqlite3, this is the name of the database that I will be creating. And then with input redirection here, I'll be opening this createtables.sql file. In order to, before I run this command, I'm going to look at this file inside of Vim. Again, it'll be very useful to have multiple tabs going at the same time inside of Vim. So to create another tab, tab E, create tables.sql like this. And I use tab completion so that I don't have any typos. And again, this create tables.sql starts off redirecting you to this tutorial, postgrestutorial.com, where you can find where these tables come from. There's two tables inside of this file up here, basket A, basket B. They're very simple tables. They just have a fruit column and an ID column. And then we're inserting some values into both of those tables with these commands right here. And that's all that's going to happen. Actually, I forgot to print out a copy of this createtables.sql file for you all. I'll bring a copy of that. Well, no, I won't bring a copy on that this Thursday. But for the quizzes, I will always have a copy of the createtables.sql file because you'll need to be able to look at this file to see what the contents of the tables are in order to run the commands. Okay. At this point now, I'm actually going to run the command right here. I'll just copy and paste that thing down here and type ls, and we can see that this quiz.db program or file was created, and I can open it in an interactive SQL session, SQLite3, quiz.db like this. And now I'm inside of SQLite. My prompt has changed, and I can do something like select star from, and then to get the table name, I'll come back over to createtables.sql over here. Again, GT switches my tabs inside of Vim, and I'll look inside the basket A table right now to see what the contents over here are. One thing that you all, again, find maybe useful when working with SQLite is changing the output down here to be a little bit more readable. I'll do mode markdown to make the output a little bit more readable, select star from basket A, and now we can see what the actual contents are like this. These empty fields down here correspond to these null fields inside of our tables. And then the non-empty ones are the actual values that we can see. Any questions so far about the setup of where we're at, what I've done? Okay. On the top window up here, I'm going to open up another file. I'll do tab E. And I will open up this quiz example1.sql file. Again, this is the shorter file, the shorter printout, the shorter handout, the one that does not have the staple in it. And inside of here, there are a number of quiz problems. And the way that you will be, what you will have to do for the quizzes is I give you a problem like this. And when we're going over the quizzes in class, I will copy and paste it into SQLite like this and hit enter. And if you have the sort of correct table drawn as the output, then you will get full credit on the problem. If you don't have the correct table drawn, then you won't get credit. For all of these problems, I'm not going to care about what the column titles are, like this right here. I don't care. What I'm going to care about is just the sort of numbers or words or whatever the values of the actual contents of the table are. So we haven't talked yet about what this is doing. We'll do that in a minute, but that's how the grading of the quizzes is going to work. Let's see. So that's what I've run this interactive session down here with this SQLite test.db. One last thing for us to go over is what these commands up here are doing. Again, this is so we're catting this file right here. This is a glob right here. So it's going to be any file that matches this particular pattern. Right now, we only have one file that matches this pattern. So only one file will get output here into this sqlite3.db. And if we run that, it'll run every SQL command in this file right here. This file corresponds to the big file that you have, or the big handout that you have, quiz_notes_1.sql. and it'll just run all of these lines one by one, and so you could see in one command what the overall output's going to be. Oops. I will do that real quick. There are two versions of this incantation, one which is maybe a little bit easier to understand. I will do this one down here. You notice that if I try to copy and paste right now, this is going off into multiple lines. So if I start doing that, we'll get an error because there's this extra spaces, and so I'll have to correct that right there. But then I hit enter, and this is the output of that quiz with the corrected answers below it. I didn't want, let's see. Okay. I was intending to do this with the notes though, so there would be a lot of things in the output, so change that to notes. And we see there are a lot of output, lots of commands being run here along with their corresponding outputs. Let's go back into our database right here and just GG, take me to the top here, and we'll talk about these commands in SQLite now, what exactly they're doing. So this command 4, on line 4 right here, if we copy and paste that down here, no such table, basket A. I think I, LS, I have a naming problem that here I did test.db, it should be quiz.db. Line 4 right here. We'll talk about what exactly is going on here. Select count star from basket A. This count function is an aggregate function, and count star over here means that it's going to just count the total number of lines in this this table over here. And the top, I'm going to switch over so that I can see what that table is. And inside of basket A, I have these 7 things that have been inserted into basket A. And so that's why I'm getting 7 lines down here of my count star. I'm going to press the up arrow again and modify this command just a little bit, deleting that count so that we only have star, and I hit enter. And we can see that we can manually inspect that there are 7 lines in this table, and that's why the count star gives us 7 lines. Again, this output's maybe a little bit awkward to work with, so I'll change my mode to markdown and rerun that, having a little bit nicer thing to look at down here in my results. Change that, adding the count star. The star over here just means that it's counting the total number of lines, not looking at individual columns in any way. Let's come back over to our notes1.sql file, and we'll look at line 5 down here, the difference between count star and count 1. In this case, this simple case, we're going to get the exact same results in both situations. What this is saying is, again, the way to debug any of these count functions or aggregate functions is you can replace or take away this count function and replace it with what's in the contents over here. And in this case, if you do select 1 from basket A, there are 7 lines in basket A, and so we have a 1 repeated 7 times. Whatever you have over here is what we're, this command right here will be operated on every row in this table over here. In this case, if you use star, star stands for all of the columns over here, so it's outputting all of the column information. If I just have 1, then for each one of these columns, it outputs 1. If I have an actual column title like ID, it'll output the IDs, ID, comma, what was it, fruit A like this. It'll output the IDs and the column information. So the first maybe weird thing to wrap your mind around is that if you have just a 1 right here, this is going to just output 1 for each one of these columns. And so a count 1 like this just counts the total number of rows. And so count 1 is equivalent to count star like this. Any questions so far about things that I've done? Yes. Question is this unique to the value 1? The answer is no. This I can put whatever number I want right here, and it does this thing right here for each row in this thing over here. It doesn't even have to be a number. It could be something like a string, hello world, like this. And counting that. It still gives you just the total number of rows. It's just a common idiom that you will see people doing, something like count 1 if they want to count the total number of rows in this table over here. The thing that is different is that if you have an actual column name over here, then these aggregate functions will not consider columns that have null values inside of them. So this fruit A right here, if I come back over to the create tables right here, we can see that, so fruit A right here, fruit A corresponds to the second thing in the tuple over here, and there are two rows with null values in the fruit A column. I can verify that by doing select fruit A from basket A like this, and we can see that there are 2 rows down here with null values, nothing being displayed. And now if I do a count and aggregate function on the fruit A like this, these null values will be ignored. They never, the count function never sees anything that has a null value inside of it, and so we get a 5 down here because there are 5 rows that do not have null values inside of fruit A. 5 rows that do not have null values, and so that's why we get a 5 right here. Change that again to a star. The star will count things whether they have null values or not null values. The 1 will count things whether they have null values or not null values. Put in a column name. It'll only count things if it has a non-null value, and that works for any column. In this case, the ID column and the fruit column happen to have the same number of non-null components inside of them, 5. As we're going through all of this SQL stuff in class over the next coming 4 weeks, the relationship or how to deal with these null values, how SQL deals with these null values will become very important and very complicated, and it'll be the most common way that people make mistakes on the quizzes and on the homeworks. So you can expect on the quizzes lots of things related to these null values. Yes, so one last thing for us to go over in this block over here, line 8. We have the ID or this fruit A like this. Let's see what that is going to do. In order to figure out what this is going to do, I will do a select and then copy the thing that's inside of the count function right here. Select that from basket A like this. And what this does, the way to read this operator is sort of as the append operator. We take this thing on the left and we append this thing on the right to it, or concatenate operator. Take this thing on the left, concatenate this thing on the right. In this case, the ID is an integer. It's automatically being converted into a string for us, and the concatenation is happening. But notice here that we only have 4 things in our output down here instead of 5. So recall if I do select star from basket underscore A like this without any typos, like this, that we had only 4 rows that have no null values in the left and the right columns over here. These 2 rows right here have a null value in one of these locations, null in the ID, null in the fruit A. And any operator you do, no matter what the operator is, if any of the arguments are null, the entire result will be null. So here our operators concatenate the thing on the left to the thing on the right. And since this is null right here, we get null as the result. I'll do one more thing to illustrate this a little bit. I will add another column to our command right here. Like this, we'll do output all of the columns and then add another column, which is this computation right here. And we can see there now in the total output here, this is resulting from the star. The star, again, is all of the columns in the table over here in basket A. So select star, this gives us these 2 columns right here. This right here gives us the 3rd column over here, so we can see what the output is and the input at the same time. And you can see down here that for these 2 rows, even though we have some values in some of the columns, because there are null values elsewhere, we get null as the result over here. And so that's why when we do a count of that same computation, count id or fruit A like this. Do I have, put it in the wrong spot, the from goes over here. We get a 4 over here as the results. Maybe the output will be easier to understand like this, just getting the 4 over here as the results. Any questions about anything from this first set of SQL blocks? Yes.
So is the general syntax that functions are lowercase and figures are?
Yeah, so great question. The question is about case sensitivity in SQL. I haven't mentioned this yet, but it's come up in the examples down here that it turns out in SQL, everything is 100% case insensitive. So I've been doing something like select star from basket A, something like this, where I have uppercase keywords over here, the select and this from. These are keywords in SQL. And it is traditional to use uppercase keywords and lowercase everything else, but it is not required. I could change this to say like something super awkward like that and make this totally lowercase from, and we get the exact same results. SQL is 100% case insensitive. Similarly, in the table names, basket A like this, doesn't matter whether the table name is lowercase or uppercase, 100% case insensitive everywhere. So that's different than most programming languages that you've probably used in the past. But that's how SQL behaves. It is customary to either make everything lowercase, everything uppercase, or to make your keywords uppercase and everything else lowercase. So this right here, this would be this would be a nice way to format a command. This would be a poor way to format the command, but either one from SQL's perspective is good. Good question. Any other questions on anything so far SQL related? Yes, Miles.
So does that mean that if you try to recreate a database,
Yeah, so if we tried to create a different table with different capitalizations, we would get an error that the table already exists. Any other questions so far? Yes. So the question is, creating the table, creating the database did not work. In my README file up here, I think I might have had inconsistent use. Yeah, so here I called it quiz.db, here I called it test.db. Those should all be the same. I think they probably should all be quiz.db. So if things are not working, then double check the file names right here. They should all be the same. You should be connecting to the same quiz or same database file that you created up here. Okay, we'll talk about more SQL commands here in a little bit, but what I want to do next is talk about how to do things inside of Postgres instead of inside of SQLite. And things will be a little bit more complicated because Postgres is a little bit more complicated of a database. So down here, I'm in the SQLite environment. I'll press Control-D to exit that environment. I'll type ls just to see what's inside of here again. Again, the only two new files that I created were this test.db and the quiz.db. I'll go ahead and remove that test.db because that's was a mistake. Type ls, and so what I want to do is I'm going to clean out my Docker environment for a second. Docker stop 202. So we have nothing running in Docker. Docker ps, no containers running. And then I will run this command right here to build the container, which contains Postgres. So run that. That's going to do some stuff. While that's doing some stuff up here in my Vim window, I'll do :tab-E and open up the actual Docker file, :tab-E and open up the docker compose.yaml file. And all of the things that are in here should look familiar to you from the previous homeworks. In this case, we have a Postgres instance. The build is the dot. That means the Docker file's in our current location. We have this bind volume right here, which means that all of the files in our current location will be accessible inside this location right here on the container. And then these environment variables down here required for Postgres to specify usernames and passwords, but they won't be super useful for us. Again, this is what we would consider a development environment and not a production environment because the data here is all toy data, and so it doesn't matter that we have like hard-coded passwords inside of here. In the Docker file, I'm installing, we're using the Postgres database right here, installing some programs that'll be useful for us inside the container. And then this create tables.sql file, the most important part of this Docker file, this moves this into this location on the container, which causes it to just execute this create tables.sql file. So just bringing up the Docker container is going to create our tables for us. There's no need to run a command that loads those files manually inside of Docker like there was inside of SQL. We'll start with the simple incantation down here, the docker compose exec pg psql. This will get us into the psql environment. Maybe before I run that, I'll just do a nice docker ps down here, make sure that things in our container are working. I can see that we now have this container actually running, and so it makes sense to run this docker compose command right here to get into the psql environment. And if you do that, then you'll now see that you have this hopefully familiar looking prompt down here that you are in fact actually inside of Postgres. Inside of Postgres, I can do \d in order to list what the containers are that, or what the tables are inside of the database. The main difference, the first main difference that we'll see between Postgres and SQLite is these sort of like administrative commands in Postgres or psql, all in admin-ish commands. There's not really an official name for this, but these sort of like administrator non-SQL commands start with a \, and then comments in SQL should be double dashes. That's how you make a comment. So I was getting a error right here that this was an invalid command because this was not a comment right here, but I used double dashes right here, so it is now a comment. So there's this line is ignored. And in SQLite, all these non-SQL commands start with a period. This \d in pSQL is roughly equivalent to the .schema command in SQLite3 that we used in the previous labs. It just tells us information about the tables that we have in the database and what their schema is. All of the commands that we've seen so far that we've talked about in this notes file, these first commands up here, they work exactly the same in Postgres versus SQLite. And so all of these 5 commands down here, no matter which ones I run, I will get the same exact output. You'll notice that the formatting is a little bit different, that this isn't valid markdown right here, for example. Postgres also tells you how many rows are in the output, so you don't have to manually count them. But the actual like contents, the thing that's important, both in real applications and on the quizzes, is going to be the same in both Postgres and SQLite. One last thing that's different is the column titles over here, but again, for the quizzes, we don't care. I don't care what you label as the column titles, and so that's unimportant for our purposes. The thing that's actually important is the same between Postgres and Postgres and SQLite here. Let's do a select count star from basket A like this. We can see here's all of our contents right here. Let's do a select fruit A like this. So we had 5 things that were not null, 2 that are null. And if I do a count star or a count on that, one of our aggregate functions, again, we will ignore the null values, not ignore the non-null values. And if I do the concatenation operator like this, then we still, anytime you combine a null and a non-null thing with any operator, you always get null as the result. And so this removes 1 more of those rows, and we only get 4 as the result. All of the results here are the same between SQLite and Postgres. Any questions about anything that I've done so far, setting up Postgres and SQLite and all of this sort of background information of just getting into a sane environment for working on the quiz problems? Yeah. Say that again? Question is, how did I make this split screen right here? And the answer is that I literally, on my operating system, on my own local computer, I just have 2 separate windows running, and I manually adjust them to be the same size that I like, fill up the screen. I have hotkeys that do that because filling up my screen is super important to me. Being efficient is super important to me. So I have hotkeys that do all the important things that I like to do all the time. I'm on a Linux system, so it's easy to set up those hotkeys. And in particular, I'm using the Xmonad window manager, which has those hotkeys built in. You all are probably not operating in that same environment, and so you will have a different system that you have to do in order to make your get a comfortable working environment. But it's still just two totally separate terminal windows that I've opened up here that I'm able to look at. So it's nothing fancy from the Lambda server side. It's only from my local laptop and how I'm displaying connecting. Good question. Always happy to answer these sort of like meta questions about how to be more efficient in the things that you're doing. Any other questions so far about anything? Yes. Great question. The question is, we've talked a little bit about pandas in that first lab, and how does that relate to everything that is going on that we're talking about with databases? And in particular, is it a NoSQL database? The answer is that pandas is what we would call a query engine, and every database has a query engine inside of it, but it also has a lot more stuff. So pandas is like an alternative to the SQL part of the database, but the database does a lot more stuff than just SQL. For this next 4 weeks, again in this class, where we're talking about how do you make SQL correct, everything that we'll be doing is there is an equivalent thing to do in pandas, but then once we talk about how to make SQL fast and those related concepts, none of that will have any corresponding relationship in pandas. And pandas also has this problem that we saw before, that it can't work on these large data sets because it runs out of memory, because it's imperative and not declarative. And so it's very easy in pandas to write code that is very, very inefficient on accident. But again, that's impossible to get super inefficient on a SQL query. That SQL will, because it's declarative, it will write the best possible imperative code that it can. And so in my opinion, SQL is much better than pandas. Yeah, at various points in the rest of the semester, I'll highlight some more differences between those two things. But personally, I never use pandas for anything because of that. That SQL is a strictly better alternative, assuming you know how to use it. Yeah.
Should we like first go through all the SQLite, then do PostgreSQL, or should we do like have 2 windows, one in which we can?
Yeah, fantastic question. So the question is, for the quiz, we have there'll be 4 SQL problems, and for each one of those problems, you need to know what the output is going to be under both SQLite and Postgres. You'll need to be able to do the output for both of these. And so how can you best efficiently study so that you understand the differences between these 2 databases? My recommendation is to sort of go like top to bottom on these notes, understanding. So here we have like this first section is about these aggregate functions and null values. Understand this for both databases, and then go on to the next section, how this works for both databases, and so on. For this first set of notes here, like vast majority of things will be the same between these 2 databases. Line 39 here highlights the only difference between these 2 databases for this first section of notes. And so let's go over, we'll go over these next few sections here until we get to that. So here we have this section right here talking about we're adding these where clauses over here to our aggregate functions over here. The way to study for these is to first understand what the thing on the left here without the where clause is doing, and then add the where clause to understand that. So again, this thing on the left is just counting the total number of columns that we have, or sorry, the total number of rows that we have inside of this table right here. Maybe one thing that I haven't mentioned yet is that every SQL command has to be terminated by a semicolon. This is true both in Postgres and in SQLite. And so if I just hit enter right here, you'll see that it goes on to a new line, but it does not actually execute this command. But then if I just put a semicolon right here, then the semicolon terminates the command and it runs this. Eventually, we'll be getting into very large SQL commands where they're maybe like 40 or 50 lines long, and so we'll be taking advantage of that later. It might be confusing at first, but it'll be very useful later that we can write long commands on multiple lines. And then, so we're trying to understand this thing on the left so far. Again, the way to understand these things, these commands that have aggregate functions in them, is to remove the aggregate function like this. And so now we have a good idea of what's in this basket A table. Now we can add this where clause over here. And if I say something like where ID equals 1, then that'll extract these two rows right here. And then so if I do something like a count star on that, we get 2 as the result. Here, line 23, this particular problem though is saying equals to null. And so up arrow, select star from basket A. I'll go ahead and delete this comment that I had too that is being tracked with this select star from basket A. You can see that there are two rows over here that have null as the ID value. But recall that equals right here is an operator, and whenever we have an operator that is equal to null, or whenever we have an operator where one of the arguments on either side is null, then the entire thing will evaluate to null. If we have a where clause with a null on the right-hand side, that means that we're not going to select from that particular row. So here, this right here will always be equal to null. This will always be equivalent to null, and so we won't get anything from this, this where clause. From basket A, where fruit underscore A equals null, like this, we get 0 rows down here. And but if I change that to an is right here, is not an operator, so this can actually check whether this thing on the left-hand side is in fact null. Change that to an is, then we get 2 rows down here where our fruit A is in fact null, and we can now add the count star to make that a equivalent to this problem up here, and so the answer to this problem is 2. The original question that stemmed all this is then how do I prepare for the quizzes? Should I then go on to the next section down below, or should I take this and rerun it, understand it in SQLite? And it would be good practice to do a couple of these in both SQLite and Postgres just to verify for yourself that they do give the same exact results. But if I'm not calling out up here that they're giving different results, then you can be confident that it would get the same results in SQLite. So I'm not going to switch over to SQLite and verify that for us right now, but this command right here behaves exactly the same in Postgres and SQLite. Henry.
So why doesn't the first one for the one select any?
Question is line 23 and line 25 up here, why do they not select anything? The answer is that we have an operator right here, and the operator has a null on as one of its inputs. And anytime an operator has a null on one of its inputs, the whole thing will evaluate to null. Whenever we have a null, so fruit A equals null, this whole thing will always evaluate to null like this. Whenever we have a null on the right-hand side of a where clause, this is null is sort of equivalent to false in this context. So this is like where false, and so it's not going to select anything. Verify that it won't select anything by putting the star right here, sees that it does not select anything. If we had a where true right here, then it selects everything. Having no where clause is equivalent to having a where true. If we have a where false, then it does not select anything because for every row, this evaluates to false. If we have a ID equals 3, then this evaluates to true only in one place, right here. Otherwise, it evaluates either to false or to null, which is equivalent to false, and so it does not select those. So if we have ID equals null, this will always evaluate to null, which is always equivalent to false, and so we get nothing. So again, the tricky part of SQL in this class, and something that if you've been exposed to SQL before was probably glossed over in your previous classes, is going to be how null behaves in the database. And again, nulls combined with an operator, no matter what the operator is, always gives null as the result. So if you want to do a check against null, you always have to use this is or is not operator. So SQL is older than Python. SQL is older than Python, but Python's none behavior, the none type is inspired by SQL's null type, and it has the exact same semantics. So null in Python, null in SQL has the same semantics as none in Python. So if you're familiar with Python, then that mnemonic will hopefully help you remember these sorts of things. Good question. Any other questions so far? Yes.
I just wanted to clarify, like, the use of the semicolon. Is the semicolon indicating a new line or the end of a sequence?
Okay, yeah, so the question is clarifying the semicolon. And so I mentioned before that SQL is case insensitive. SQL is also white space insensitive. SQL is white space insensitive. And so this is how most programming languages behave. Most programming languages are like this. Languages are like this. But notably, the shell and Python are not. Shell and Python are not. And Python is extremely white space sensitive. Python sort of infamous for being very white space sensitive and sensitive. And people are very picky about that, or a lot of people don't like Python because of its choice on white space sensitivity. So to illustrate this a little bit, I will rewrite line 23 right here as a multi-line command. So I'll do something like select count star from basket A, where fruit A equals null. And you can see that it's only after I had a line that contained a semicolon that this whole thing was actually evaluated. That's because this new line over here, when I hit enter, has no semantic meaning from SQL's perspective, and so this is not a command by itself, and so it does not get evaluated. In the prompt over here, you can see that the big lines that are starting a command, they have an equals over here. Lines that are continuations of a command have a dash over here. So these lines right here are continuations of this line up here. But the only thing that a semicolon does is it signifies that whatever you were typing in previously, that is the end of a command, and we'll move on to a new command. It's perfectly fine also to have something. I'll do a very simple command right here, something like select one. There's no table on the right-hand side, but it still outputs one right here as the result. We could also have combine multiple commands onto the same line like this by separating them with semicolons like this. So the only thing that a semicolon does is it separates one command from another, and unlike, say, the shell where it's optional, in SQL it is required. That answer your question? Good question. Okay, last thing that we'll cover today is this this like operator. This is the thing that behaves differently in SQL or in SQLite and Postgres. And so we won't fully cover it today, but we'll at least introduce the idea here. So again, there's this American National Standards Institute that writes what is the SQL standard, which is what every database is supposed to aspire to being fully compatible with. But no database is 100% compatible with the ANSI standard. Postgres is famous for being the most standard compliant database. And other databases for sort of backwards compatibility reasons are less compatible. The first incompatibility we'll see is the behavior of this like operator. Like lets us do things sort of like the glob in the shell. And so we'll just do some examples here inside of Postgres and then talk about how SQLite is different. So we'll take a look at this command right here. And again, in order to understand what this command is doing, I will start by deleting the aggregate function over here. And now we can just look at the actual results. The like operator takes a column on the left-hand side, and on the right-hand side, it finds a pattern that it needs to look for. And so here the pattern is saying that somewhere inside of this column value over here, we should have the letter A, and it must, the percents over here is like the star and glob, so it can have anything we want before, 0 or more characters before, and 0 or more characters after. So in this case, both orange and banana match that. But we'll notice that, so I'll delete this whole where clause for a second. You'll notice that there are in fact apples inside of this table. There are in fact apples here, and but like by itself is case sensitive according to the ANSI standard and according to Postgres. Like is case sensitive, and so this A right here does not match the apple right here. If I press the up arrow, rerun this with a capital A right here, we'll see that we match the apples, but we no longer match the bananas and the oranges. In Postgres, in order to do case insensitive pattern matching like this, I need to put an I in front of the like. I stands for insensitive, and so we do that, and we match apple, apple, orange, banana with a capital A, or with a lowercase a, also match apple, apple, orange, banana. This is SQL compliant behavior, ANSI SQL compliant behavior. SQLite3, however, decided, and this was a decision they made decades ago, so it's not something they can change anymore because they need to maintain backwards compatibility. But SQLite3 decided that nobody really ever cares about case-sensitive comparisons. We really only ever want insensitive comparisons. And so they just made the like operator case insensitive and did not they did not implement this I like operator at all. And so in SQLite3, I'm not going to go through it right now, but if you were to run all of these operations, you will get different results in SQLite3 than you will in Postgres. And in particular, some of these commands that use I like right here, those will throw an error in SQLite3. For the purpose of the quiz, if you get an error from running a command, all you have to do is write error, and you get full credit. You don't have to write out what the full error message is. Yes, question?
For the purposes of the quiz, should we assume we're running it on Postgres or SQL?
So for the quiz, the expectation is that you tell me the output from both. So if this were a quiz problem right here, then you would have something like this would be the output from SQLite3, and something like this would be the output from Postgres, and you'd have to draw both of those. Vast majority of times, the output will be the same, and you can just write a note saying the output's the same. For this first quiz, the only way the output will be different is if there's a like or an I like operator in the problem somewhere. I see there's more questions that people have. This is a good stopping point for us, though. I don't want to go over time. Happy to take more questions after class, though, and about anything about the SQLite stuff, about the homeworks, whatever. And this will be our end of class for today. Again, no quiz on Thursday.